Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome to another episode of the Reliability Matters podcast. I am so glad you're with me today. Thanks for being part of our podcast family. And speaking of today, it seems today the entire world is experiencing supply chain shortages and challenges in nearly all product categories. In the electronic assembly industry, the focus has been within the semiconductor market, especially in North America. We know that as the great chip shortage. Why is this? How did the U.S. and the rest of North America allow this to occur? Was it short-sightedness? Was it greed or an over-reliance on foreign suppliers or other factors or a combination of all of these factors? And what would it take to finally address this issue? And are we doing anything about it? My guest today is Matt Kelly, Chief Technologist at IPC, one of our leading industry trade organizations. IPC recently published a report on the chip shortage and perhaps most importantly, came up with a list of 28 recommendations our industry can consider to remedy this issue. As I stated, Matt Kelly is Chief Technologist at IPC and is focused on driving the next generation technology advancements and supply chain transformation across the electronics industry. He works within the association's executive leadership team to identify and develop new strategic initiatives meeting member and industry needs. He delivers influential thought leadership, research, and advocacy to industry and governments. He leads IPC's Chief Technology Council to continually drive the electronics industry forward. His focus areas include Industry 4.0, Factory of the Future digitization, modernization, adoption, and implementation, IPC expansion into new advanced packaging technologies, including IC-substrates and OSAT manufacturing, and next-generation electronic systems design methods. When I first met Matt, he was with IBM, and Matt comes to IPC following a 15-year career at IBM, holding several senior technology and engineering leadership positions within IBM Systems Division. His technical contributions include 25 patents, 85 publications, and numerous industry awards. Matt is a licensed professional engineer with a degree in chemical engineering from McMaster University and holds an MBA in strategic management from Sir Wilfrid Laurier University. So without any further ado, let me bring in Matt to the show. Hey, Matt, welcome back.
Hey, Mike, how are you?
I'm well, thanks. I hope you are well as well. I am in Southern California. You are quite far away from me. You are in should I say the greater Toronto area? Is that?
I am. Yes, I'm sitting here in beautiful Toronto, Canada. So thanks for having me on the show. It's always great when we get a chance to catch up.
Yes, and you and I saw each other not too long ago, a few months ago in Toronto, and we were just talking before we started recording. We were so close, but so far. I wanted to talk to you about this subject, and we just kept circling around. And every time we got close to talking, someone would tap us on the shoulder and distract us, and we never really got to do it. So I'm glad that you're with me today. I think this is an extremely important topic. This show is about reliability. So how does the future of U.S. manufacturing, the semiconductor shortage, all that kind of stuff, fall into reliability? Everything falls into reliability. I can definitely connect dots because right now the chip shortage is leading to an explosion in counterfeit and reuse of old components and sometimes hastily redesigns to find components that can be used that are not in as short a supply. And whenever hasty decisions are made or counterfeit comes into the picture, that certainly affects reliability. One thing that is important to reliability is a sustainable, predictable, reliable supply chain. And when that breaks down, it has all the dominoes fall, and so I think it's a very important subject. But before we get started, real quick, a personal question. You worked at IBM for 15 years. My father was a programmer in the 60s on IBM mainframes, and he used to bring me to his office on weekends when he was doing like a giant coding project, and back then in the 60s, you didn't sit at home on your laptop wearing headphones listening to heavy metal. You were in the office on key punch machines, and he used to let me play on the key punch machines. And I thought I was Captain Kirk. I thought I was, I'm in the lap of technology. But in the course of going there over several years to his office, I was talking to a few IBM employees when I was probably a teenager by that point. And IBM, of course, the acronym is International Business Machines, but they all had a different acronym for it. They said it stands for I've been moved, because back in the day, if you wanted to move up in the company, you had to show your willingness to be a company man or a company woman, and you had to show your loyalty by agreeing to move, and they'd kind of test you and move you around the country. Was that your experience? Did that particular business style end by the time you started, or was there a little bit of truth to that when you were there?
No, I mean, the model's changed significantly. I think COVID has kind of fueled that as well. So there's a little bit of that. I think it depends on the type of function that and the experience that you're trying to gain. So I don't know if it's necessarily moving for moving's sake, but with big companies like IBM, I mean, there's lots to see and learn and understand, especially getting out of your comfort zone. So I think that was the reason. But no, a lot of collaboration. It's how the supply chain runs. Monday to Friday, and when you can or you have to go to a facility, quite frankly, it costs a lot of money these days to be flying places, and
Sure.
not just in terms of money, but in terms of the time. So the internet has allowed people to stay a little bit, where they live and
Sure.
and that sort of thing.
Yeah, I'm sure there's other ways to prove your loyalty as a company person. They did hand out these. I don't know if these were a thing when you were there, but this was something my dad got in the late 60s or very early 70s. And this is what they gave out to customers. You buy a
Still the mantra today. Yep. No,
$100,000 computer and they give you a sign that says think. But what a great advertising. It doesn't, it says in very tiny writing, compliments of IBM Corporation, but just the mantra of think. How much further ahead would our industry be if we practice that little advertising slogan? Think. All right, let's get on with the subject at hand, a little bit more important than IBM's employee promotion program, and that is call it the chip shortage. I mean, it's a shortage of everything today, but the poster child is a chip shortage, and that's what really falls on our lap. And during our conversation today, we're going to make a few references because these were references in an article that you were involved in producing for IPC. One talks about Moore's Law, one talks about advanced packaging, one talks about OSAT, OSAT. Much of my audience is deep into this industry, some kind of orbit around this industry. So just to clear the playing field, let's kind of start with the beginner's mindset. You refer to Moore's Law in the article. So explain to me and my audience, what is Moore's Law and how has it changed over the years?
Well, Moore's Law is named after Gordon Moore, who made an observation that at the rate and pace that they were going back in the time, that the number of transistors that you could fit in a given area would double at a certain rate. What that does is it increases the speed and the capability of that silicon chip to be more powerful, to run faster, and all these sorts of functions. So it's been a linear progression over many years. The trouble is as we're getting into the feature sizes that we're at now, the economics of, while we can physically do some things, the cost and the ability to actually produce such a structure is now becoming cost prohibitive more and more. So the idea of Moore's Law is that it's really just a way to describe, miniaturization of transistors, but it's running out of gas because it's becoming too expensive, is the way it is. And so that's what's really driving this new notion of heterogeneous integration and chiplet architectures, which is really what this is all about.
Yeah. Well, if you go back to the old Intel days, in the early days of the PC, the first PC was about 4.7 megahertz, and then it went to 16, then it went to 32, then 64, and every year or so, the speeds would double. And then at some point, the speed started going up by 50%. And then the next chipsets, the speeds were 20% faster. And then the next chipsets, they were maybe 5% faster. So the doubling does have a lifespan, clearly. Moore's Law was it was true and tried and proven until it wasn't. And it's probably still possible, but as you point out, it's not practical. The costs to get to that next level was prohibitive. In fact, engineer at Intel told me the reason why the next chips are not doubling in speed is because Intel needed to have the next generation chip twice the speed of the one they were about to release completed so they could use it to test the new chip. And the ability to go twice the speed to test a chip at half the speed was cost prohibitive. So the rate of advancement started slowing down. I'm going to, let's define advanced packaging as opposed to less advanced packaging, just for our audience sake.
This is my favorite question because we get excited with, we start talking about semiconductors and silicon and advanced packages. And I think the easiest way to describe an advanced package is that it is an electronic component. It's a certain category. It's classified as logic. The different types of functions that this advanced package world can handle are things like compute, memory, storage, mixed signal, analog, digital type of conversions. There's a variety of things, but it's an active component. It's actually in the circuit. It is, think of it as the brain. The best example for your listeners would be, Intel inside your laptop. You probably, Intel or AMD or some processor sticker that you can look at, and it's processing the information. The other main area is memory, and that's actually one of the fastest growing areas. You've seen a switch to solid state and flash and other NAND type of memory structures. So it's a very important electronic component that is used within literally every electronics product, in terms of application. So it's a very wide and a very big space. We can talk a little bit more about that.
Sure. And then you also make references to OSAT, OSAT. That is an acronym for
outsourced semiconductor assembly and test. And so the best way to think about it, that is an EMS company. So an EMS provider builds a final assembly for an OEM. An OSAT provider builds the final component for the component OEM.
Yeah. Okay, good. Well, thanks for defining those terms. If we stumble across some terms that we have not yet defined, I may stop you and we'll bring our audience up to speed. I'm going to read a little bit of a page here because I'm going to quote you in the article that you were involved with so that we can bring our conversation into perspective. You stated in your article that North America lags behind Asia in capacity, but technical capability is a source of concern as well. Asian manufacturers also dominate the printed circuit board, PCB, and electronic manufacturing services, EMS, ODM, sectors, where outsourcing and offshoring have been prevalent over the past 20 years. Asia's dominance in electronics arises from the region's breadth of manufacturing capabilities, from chips through advanced packaging, through PCB fabrication, and final hardware and system assembly capabilities. So my question after reading that, is what are some of the factors that led to Asia's dominance and North America's lag in these technologies? In other words, how did we get here? That's probably a small question with a giant answer, but
it's a great question, and I often ask myself that as we work through this. Essentially, this is a 25-year now problem that has been developing slowly but surely. So if you kind of rewind back into the late 90s and you were to do a cross-section of companies that were in North America, and also this isn't just about North America, this is other regions. Europe is also has experienced this as well, where there was many more printed circuit board fabricators regionally. more EMS regionally, and kind of that more that we'll call it that ecosystem. You hear me talk about this throughout. There were more players, but as we learned that we could, get at labor components and some of those kind of aspects to the cost side, outsourcing began in this industry. And so now, if we fast forward, 25 years, the receivers of that technology have learned a tremendous amount, and it doesn't matter where it is. As an engineer, I'm a firm believer. There's a couple key terms that I like to use. Manufacturing matters. If you don't build it, you will have gains originally in profit and other things by saying, I don't have to build it, I don't have to deal with this overhead. But eventually, you won't know how to make it anymore, and
Right.
so you don't realize you're losing that capability. So that's really been the genesis of. Across several sectors and for this audience, I'll kind of focus on the PCB and the EMS industry that happened together. And so we find ourselves in this, COVID was a good example where if there's any ripple in supply chain, and you don't have the ability to build or, at least second source protect what you're trying to build, that's when people get really nervous.
Yeah. I think manufacturing is much like languages. There are some languages that have died throughout history, and if you stop speaking it and you stop teaching your children that language, it dies and never comes back. And I think manufacturing is the same way.
There's a
Once you give
really
it up, you can't get it
famous.
back. Mm-hmm.
Yeah, there's a really. I don't know if famous isn't the right word, but there's a very important Harvard Business Review article, HBR article, that I always cite, and it's dated 2009, and it's called "Restoring American Competitiveness." And if you read that right now today, you can change out some of the examples of the electronic. I think it was a Kindle that they used in the article, but you can read it and just realize how important it is today. And they talk about things. There's a term called the commons, and so you need front end. Type of technologies with PhD level kind of type of work, pure research, all the way down to having the facility there, having technicians do it, shipping crews, warehouse crews. I mean, it takes that village, right, to make the element, and
Sure.
it's amazing how telling it is today.
Yeah.
And that's really the root of this is the 20-year, to answer your question, the root of this 20-year decay is now upon us.
Yeah. The fact that article was written 13 years ago and still applies 100% to today, it just tells us what we learn from history is we don't learn from history. In your estimate, best estimate, what's North America's share of the advanced packaging semiconductor chip market?
Well, there's a few different ways to look at it. If we look at it from a there's three that I'll cite. So if we look at it from a semiconductor design aspect, North America still holds about 85%, 85 of that global share. It means we design a lot of really good things in domestically, with about 5% kind of in other regions. I know that doesn't make up 90, but there's or 100, but that's roughly what the share is. In terms of manufacturing, that same advanced package, it's only about 12% in the U.S. versus 75 in Asia. And then in terms of packaging, right now today we estimate about 3%, with 97% being done elsewhere. So you have to look at it from a design, a manufacturing, and a final packaging element, I think, to really get the full picture.
Right.
And all those numbers aren't very good.
It sounds like North America is somewhat the king of design. We just don't want to build it. Let someone else do it. But
in fact,
that
that's
seems to be the mantra, right?
Yeah, it's basically what this says is that we can design the most state-of-the-art systems in the world, but we can't build it.
Yeah, and that puts us at a strategic and all sorts of liabilities from a economic standpoint. The design is great if you can get it built, and now we rely on other factors, other countries, other people to build it. And from a even national security standpoint, I think that's a little scary to think that, like rare earth minerals, that are used in every guidance system and every cell phone and communications technology that we have. We closed our last rare earth mineral mine years ago because we could find other people willing to get their hands dirty. We didn't have to do it. It was cheaper. And now we rely on people we are not at war with, but we are at a Cold War with for our own strategic strength and economic strength. And that's, to me, that's incredibly frightening. And I shake my head how we get here. And the way you described how we got here, it makes a lot of sense, but it's still surprising. So,
and this is true, Mike. I just wanted to highlight too. I mean, IPC is an international trade association, and one thing, while the report and a lot of the work that we were doing was North American based, once we published that report, we were hearing very similar things with our European members and companies there, where while they had strengths in certain areas, there was still a lot of these same messages and recommendations that would be applicable to them. So I want to kind of talk about this in terms of regional, where several regions are experiencing this.
Yeah, it's probably almost. It would be just as applicable to rename the report Western rather than North American, because I think just to define it as Western, I think we share a lot of the same concerns, slightly tweaked in certain categories, but it still is a major concern. The folks in Germany and throughout Europe are outsourcing, every bit as much as we are. Maybe not quite as much, but a lot more maybe than they should, to avoid what we're seeing today. This kind of just came in between the time we talked about having this conversation and today, and that is the Chips for America Act, or the CHIPS Act. Part of that was signed, was approved, and I'm not caught up yet to know, was that just a House approval and it has to go to the Senate, or is that ready for the president to sign into law?
This will be signed by President Biden next week.
Okay, so it cleared, and my understanding is that's about a $20 billion federal investment deal. Is that about right?
No, $52 billion.
Even better, $52 billion. And where is that money going? Is that going to build foundries in the U.S.? Is that going to be split up into a number of different categories? What's your take on that?
Yeah, and that's what the focus, the change in focus has been. I mean, if you kind of back up, a lot of this has been happening very quickly. So even with less than a year ago, you had companies, North American companies, advocating that this is needed, and it was really explaining the importance of this and what was needed, what was lacking, what the gaps were. And so with the signing of this, what it really now will turn into is it'll switch over into implementation, just exactly what your question is. And so there are all individual companies are looking to see how they can participate in this funding with just company to company type of approaches. But there's also been some industry coalitions that have formed, of which IPC is part of two of them. I can mention ASIC. It's the American Semiconductor Coalition, led by New York Creates and IBM. And then there's the other one that we are part of. It's MITRE Ingenuity, and based out of Washington. Again, not calling them, they're not competing. It's just there's been different groups that are kind of trying to do similar things. And so there's a coalition-based approach to this as well. And what is interesting, I will say, is if you look at what's happened, I do say this with a bit of bated smile coming from industry, is that we've actually received money first with the plan second. And that's usually a little backwards. Usually you need to go in with a plan to get the money, right? So
Sure.
that is being worked out right now. It obviously with so much money and kind of needs and positions, it's very difficult. But I'm very hopeful. I think just the signing of this is a very good sign. You mentioned earlier everything is important for reliability. There's another thing that always has rooted me, and that is everything follows silicon. Everything.
Right.
And so with this, however this unfolds, there's going to be winners and losers and people that are happy and unhappy. But eventually, just that injection of $52 billion here will be a catalyst to do lots of different things. This will ripple into substrates and OSAT and even PCB and EMS industries at some point, because these advanced packages are changing dramatically. And if we can talk a little bit about that, I think it would be good in terms of the architectures and what's coming, because it's a very big change.
So we already struggle to build. In some cases, we just don't build current designed packaging. It seems to me with the proliferation of just simple things like bottom terminated components, starting with BGAs several years ago and to flip chips and things like that, we're not building those parts for the most part here. I could only imagine, based on the speed of technology and the speed of advancement and the constant revolving door in terms of product design, if we can't build what we're using today, how can we build what we're going to be using tomorrow? Will we just skip what we have today and just start concentrating, take that $52 billion and start putting it toward tomorrow's technology? Or are we going to have to spend half of that to just catch up to build resistors and capacitors and in simple things? Or, where do we say, okay, we're going to start here, or do we just try and be everything to everybody? Or do we just say, okay, we've lost that, we're fine with that, we're just going to build the next gen architecture?
Yeah, it's such a great question, Mike. Just to put it into context, if you look at the kind of the top 5 OSAT houses in the world, and you ask them how many different advanced package schemes do they support, they will say 1,000. Think about 1,000 different combinations that mean the same thing.
Mm-hmm.
Advanced packaging, right? So it's very broad. So that in itself, you need to your question, determine what needs to move, what can move, all of these types of things, right? So you have to be very selective in what we're talking about, and that really comes from the systems and the application that you need to build domestically. Mm-hmm. Right. So, for example, the easy one that everyone will cite will be, we need to have certain infrastructure that's available that we could build and design here, or in any region locally, right? And so you may be willing to pay some extra premium to have it built domestically, but you're doing it so that you can have continuity of supply and those types of things, right? So the markets that we definitely see, the obvious one is defense. Any regional area wants to make sure they can support their defense market. But we also know that a defense-only demand is actually, believe it or not large enough. It doesn't have enough volume, and it's just not economically viable for the supply chain companies to only do that, right? So defense plus high performance computing is definitely on the list. Automotive, EV type of applications, and medical. Those would be, as well as base utility infrastructure type of markets. If you were to start to think about the products that are in those segments and say, yes, you need to build them domestically, then you can start to continue to unlayer and say, well, what type of technologies are needed for those? And so that's kind of the approach. I realize it's like a top-down view, but just to basically say, these are the types of technologies we need to build. It's actually looking at it the wrong way. You have to kind of have it from the application and the demonstrator point of view. so that you can define, what's going to actually make it happen.
Yeah, that makes a lot of sense.
That makes sense. Yeah.
No, it makes total sense. Sounds logical. You state in your article that there is almost no capability in the United States to produce the most advanced IC substrates called flip chip ball grid arrays. The U.S. also has very limited capability and capacity to produce lower end wire bonded substrates. You further state that the U.S. has a 20-plus year market leader know-how gap, a weak sub-tier supply, skilled workforce shortage, and a lack of raw materials. What would it take? I agree with all that, by the way. That seems very evident. What would it take for the U.S. to remedy this? We talked about how we got here. How do we get out of here?
Yeah, so there's a near term and a long term. So the near term is let's use IC substrates, for example. This is not a bring it back to the region story for IC substrates. This is basically obtain that capability for the first time. Now, there are niche applications and capabilities in the country that can produce limited volume and kind of prototype levels of IC substrates here, but it is nowhere near volume production level. So in the near term, printed circuit board companies that might be dealing with HDI type of technologies might find it interesting to extend into IC substrates. Now, there's a fairly big gap there in terms of, as you mentioned, workforce training and also all the know-how and things. But there is potentially a pathway there where existing companies can get into a higher level technology domestically. In terms of the assembly side of things, this is where EMS production that would be building more system level boards might be able to enter into production of components, in their assembly facilities. Now, you're going to need things like clean rooms and some, this doesn't come out without a price tag, but it is doable. Equipment sets in some cases are similar. They still use pick and place. They still use reflow ovens to do a lot of this stuff. There's a lot of thermal interface materials. So it's again, that similarity between those worlds. So those are two examples that I would give where companies can actually try and get into the market because this in many cases will be having companies do something they haven't done before.
Sure.
Including IPC. I mean, we are getting into this advanced packaging space, and it means we're dealing with new companies we haven't dealt with before. And, I think that's just kind of a sign that there is a slightly different technology area that there's a lot of opportunity here.
IPC has several pillars, one of them being education, one being advocacy, one being standards. I would think advocacy, I think that leg is probably disproportionately more muscular than the other legs that IPC stands on recently, just because of recent times, be it through COVID, through recessions, through trade wars, all the tariffs that happened, last administration that still haven't been cleared up for the most part. I would imagine the advocacy group is going, hey, we need a vacation, guys. We're working overtime.
Yeah, and I mean, it's also a sign of the path that we're on. I mean, a lot of this, as I mentioned earlier, was just being the voice of industry. It's exactly the intent of IPC is to say, speak in a louder voice as opposed to siloed companies only, and say these are the things that are needed, and letting people realize the risks of where we are today and just calling it out. And I think this report, for example, has been on the desk of the Department of Commerce, Department of Defense, Department of Energy, NIST. So we are very tightly integrated with some of that decision making. It's hard to tell how much influence our effort had as a singular effort, but a lot of groups have been doing this, and I think that's why you've seen the CHIPS Act. People really pay attention because there were so many groups and companies saying we can't not do this.
Right. I don't think the general public cared a whole lot about the chip shortage until they couldn't get their favorite feature in their Ford or their GM car. All of a sudden, everyone cares about the chip shortage now, right? Because it made it harder to buy certain features in certain cars. Would adding domestic semiconductor fabs, fabrication foundries, without domestic IC substrate supply and OSAT assemblies, lengthen or shorten the supply chain, in your opinion?
Lengthen, absolutely lengthen, and that's the key message. You talk about advocacy. While we applaud the amount of effort and focus and the need that needs to occur within the semiconductor industry, the raw silicon, that's what's really making these changes for advanced processing, for artificial intelligence, for all kinds of new applications. The reality is that it's just one part of a larger ecosystem. So fabs, one fab, by the way, just in terms of round numbers. So you can think of there's Samsung, TSMC, Intel all have bulldozers running right now. The sites are well on their way. $20 billion for one fab. That's to build it. $5 billion maintenance roughly to keep it going at the latest node. I mean, these numbers are astronomical, right?
Right, and it's not built in a week either. I mean, it takes a significant time to
3 years.
3 years. So even if every country in the world dedicated billions, trillions of dollars toward building 20 new foundries, we're not going to see anything for at least a few years before.
Well, actually, the gate from us. I'll give you one example in terms of substrate. So even if you said, "Okay, I'm all in. I want to get into this market," you'll be on a 2-year waiting list for fab equipment.
Right. So we're talking about several years before we see the first chip roll off the assembly line.
No, well, it's coming fast. 2023, 2024. So, but people are already ahead, right? Remember when the public hears this, it's already in motion.
Right. We are addressing it. It's just it's in play right now.
Right. So to get back to your question, semiconductor, absolutely important. Everything follows silicon. But you don't hold a piece of silicon in your hand to talk to me or to communicate with me over this podcast. It's packaged in a component, put into a system that you hold a phone in your hand, right? So it really depends on where you draw the line. So there's silicon. That silicon basically goes on to a substrate of some sort. And that substrate is built by an OSAT producer or some other assembly test house to put it all together. And it's not until that point where it becomes a finished part number that you can buy, that you can put on your board, that becomes a system.
Right.
And so it's having semiconductor fabs and foundries only will just create bottlenecks elsewhere in the supply chain. So that's why we cannot forget about these other legs of the production cycle.
Sure. You referenced OSAT producer in your answer. On that subject, there's just one U.S. headquartered OSAT producer in the top 20 globally. It's second overall. And while this company is headquartered in the United States, it does not have assembly plants anywhere in North America. What would it take to convince, say, that company or any company for that matter in the same situation to reshore assembly plants back in, I don't want to just say United States, but North America, since we're talking about North America, or the West, if we want to make it a larger region that's experiencing the same issue? What would it take to talk to convince that company or any other in that situation to bring it back? Bring it back. It's time to come back home.
Yeah, it's the simplest answer is it has to be a sustainable business model. And that's really the problem, is that even with, we have to be careful about getting too excited with these subsidies because while there'll be a lot of things that happen with this subsidy money, and we can even put it against a few years or several years, it will be a subsidized and kind of artificially propped up condition. And so unless that subsidy continues, you'll have to have a successful business model to last the longer term. And that's what's really the sticking point for, kind of the case you gave here from the OSAT company, where you can lure somebody, I guess, if I can use that term, with some money, but you have to show that demand in the market, lasting beyond 5 years. That's the last 10 years, 15 years. I mean,
Sure.
again, with all that infrastructure installation, this has to be a sustainable business model. So it's as simple as that.
Yeah, I spent a lot of time in Scotland because that's where my family's from, that's where my wife is from. And I remember there was a particular town in Scotland that attracted a bunch of tech companies. Tandy, back in the day when Tandy was a company, was there, and other computer manufacturers were there. But they were there for the subsidies. And probably I'm not far off by saying literally to the day, those subsidies expired. They're gone. They were gone. And now there's all these, empty factory buildings, or there was empty factory buildings for a long time because they were there for the subsidies. And to your point, Matt, the CHIPS Act, the investment in federal dollars, is like starter fluid down a carburetor. It'll get the car started, but it's not designed to be run on it. And there are countries in the world where, they're designed to run on subsidies. That's just the way the government works. We're not one of those. And it's very rare for the U.S. to subsidize business, private business. It doesn't happen very often. It has happened over time. It hasn't always been successful. But I think to get us out of this situation, there are certain things that are just too big for civilian companies to deal with. And it takes the full credit and financial resources of a federal government to remedy the past 25 years worth of, in hindsight, mistakes that our industry made. Probably weren't mistakes in real time. They probably made sense in real time, but in totality, cumulatively, they became one big mistake. So IPC published, the whole reason we're talking is IPC published a paper, so to speak, with 28 recommendations to rebuild the U.S. advanced packaging ecosystem and reinforce the effort to expand domestic semiconductor manufacturing. Can you walk me through, we don't have time to go through all 28 steps, and maybe it's down to 27 because we just got $52 billion. So maybe that was one of those steps. But what were some of the notable recommendations that IPC made that the U.S. or North America or the West in general can adopt to help remedy this situation?
Yeah, and I'll just kind of walk through a few of them here. But I mentioned earlier that manufacturing matters. I think that's absolutely our number one recommendation. The manufacturing and that ecosystem approach as we move forward now through this next period in time, that we need to make sure that we understand this concept from thinking about new technologies at the design side, but then getting all the way through and figuring out how it's going to be manufactured, as well as things like sustainability, like how can we recycle it or reuse it or modularly design it. I mean, all of these, there's lots of topics in here, but you can't do any of that if you're not manufacturing it. And so I am not naive in the sense that the global supply chain is alive and strong, and it will absolutely continue. But the way that I think about it is kind of like at your, especially in the summertime here in Toronto, there's this campaign of buy local, right? So you local berries and vegetables and things, and support your local farms. It's the same thing as it's like a regional plus global supply chain point of view, not just global supply chain at all costs so I can get an extra point or two on my margin. I'm exaggerating a bit, but I think that's far and above the biggest recommendation that we really got to make sure that we manufacture. It has a lot of implications, like you build those facilities, you don't want them to be empty, you need people in them, but you need the demand to make it economically viable. So it's a very complicated endeavor, but we need to be, manufacturing has to be a little bit more exciting and put on the top of people's lists.
Yeah, it makes
The
a lot of
other
sense.
recommendation is what I would call silicon to systems. And I've mentioned this before, that everything follows silicon. with these changes in heterogeneous integration and chiplet architectures, make no mistake, this will show up in the printed circuit board industry and in EMS eventually, with a whole bunch of challenges. Companies in these spaces just may not see it yet. So I would recommend that everybody really pay attention to what's happening technically in the semiconductor world and the packaging world, because this will fuel the next 10 years plus of growth in our industry.
Yeah, excellent.
And then, there's a whole bunch in here. I'm just kind of looking through my list here. I should mention the concept of heterogeneous integration and chiplets. So if these are new terms to you, I would recommend spending some time looking them up. But basically, we started the conversation with Moore's Law. And, for a fact, Moore's Law is essentially dead. And so if we're going to continue at this rate of pace with functionality and speed and all these things, we have to find new design methods. And what chiplets are and heterogeneous integration is combining chips together. It's like multi-chip modules back in the day, so that you can get memory and compute and all these things you're trying to get the package to do, all within the same package. So you'll see stacked memory, for example, all kinds of different configurations. So the recommendation I would give is really spend more time in the heterogeneous integration and chiplet area. Some of it gets quite complicated, but at least be familiar with what this technology is driving.
Sure. We're going to have to wrap up soon, but there are a couple of questions I do want to ask you. Number one, we're all in this industry. We're all stakeholders in this industry. We all have something to gain or something to lose for how this all plays out in our industry. What can we do as stakeholders in this industry to help support the efforts, either IPC's efforts or other efforts that will help turn around North American, Western in general, manufacturing? What can we do? What can I do as a business owner in our industry, or anyone else do for that matter, to support this type of effort?
Well, I think the very first thing, again, in terms, and I love the question, Mike, because it's, we've talked a lot of philosophy and kind of status of what's happening, but like, what can I do in terms of call to action? I think the number one thing is really just get educated. You talked about advocacy and how, we were tired on that side with everything we've been doing. But it's very true. If you're not familiar with what is really happening, a lot of people will nod their head. I know what advanced package is. I know what a semiconductor is, but there is more going on right now than ever before in this industry that I've seen in my 20 years. And so really read up on those types of chip architectures and what's happening, because those developments will spin off into materials needs, qualification needs, reliability needs, assembly challenges, all the things that will come from this. And because if you don't understand the base technology, then you really can't offer up new material sets or new cleaning methods or new assembly processes, those kinds of things.
Sure. And before we say goodbye, I want to ask you about a symposium that IPC is announcing right now on this show. You heard it here first. Tell me about that symposium. Where is it? What is it? When is it? What is it all about? Who should go?
Yeah, we're really excited. This will be IPC's first advanced packaging symposium, entitled Building the IC Substrate and Package Assembly Ecosystem. It'll be held October 11th and 12th. It'll be held in Washington, D.C. this fall, and held at the Kimpton Hotel Monaco. So we're really excited that we're able to get the right people together. What's really interesting is that the lineup of speakers are, it's very deliberate, the agenda. It's been fully curated, and it has a top-down agenda where we're going to talk about updates from groups like the Department of Commerce and Defense on what is needed at the high level, but then walk all the way through from component OEMs, IC substrate manufacturers, PCB suppliers, and then keep going down into material suppliers. So we have a really good group. I can name a few. We've got AMD, Amcor, ATS, Veritech, Calumet, IBM Research, NIST,
Wow.
Schweitzer. So we've got a very
You
good
got
list of
you got the
people.
A team showing up.
Yeah, and it was, it's just extremely timely. Again, with that CHIPS bill being signed next week, the focus is turning to implementation, and so that's what the symposium will be all about. Is about converting those challenges, but into what companies can actually do about it.
So this is this a symposium designed to be attended by manufacturers of advanced packaging product, or is there any end user participation or interest?
Yeah, absolutely. I mean, we've got a cross section of the component and device makers like AMD, Intel, IBM. We've got system users like Northrop Grumman. We've got IC substrate producers like Semco, ATS, and new entrants like a Veritech and Calumet. So, yeah, it's really trying to touch the different spots in that supply chain, and then also talking technically and business wise, through the 2 days. It's a 2-day event.
Interesting. Okay, last question. First of all, for my audience, if you're listening, look at the show notes on your podcast app. I'll have information on that conference and information on the IPC article, recommendation article that we've been talking about, all listed there. If you're watching this on YouTube, look down where it says "Show More." Click on that, and you'll get links to the symposium, the conference, and the article that we're talking about. Matt, final parting question. Get your crystal ball out and look into it deeply. Where do you see North American manufacturing in the next 10 years?
Next 10 years. I think we're going to continue our strong design capability. I do think that we will continue to have this economic challenge of, what we really can build here in volume. But as we've talked about in other shows as well, these concepts of factory of the future and automation, these are ways that companies can actually become more competitively viable for the long term and sustainable. So what I would hope for would be companies in North America, now while not explosive, but a fair number of good cases where we are actually producing these key components like we talked about through your show, and being healthy companies. Kind of in a lower volume, high mix scenario that is highly automated, that is efficient with low scrap. I know now I'm starting to rattle off everybody's wish list, but pointed in that direction. I think these factory of the future concepts it's directionally correct. The adoption is still slow because of capital requirements, but I would like to see the adoption of some more advanced process techniques and use of data to make North America more competitive, in the advanced packaging space. Along with that, there still will be a strong global supply chain component to this. I mean, the example I give are capacitors and resistors. We are not moving a world-class resistor factory from Southeast Asia to North America as a completely different example, right? I mean, the global supply chain will be needed, but I hope that there's a little bit more of a balance on what can be built, so that there is more resiliency and sustainability built into the supply chain.
Sure. I think what we really need to do is bring back this, put it on everyone's desk, as we started the show with. We need to think about the future of North American manufacturing. We were at a time in our past, not too distant past, we were the manufacturers of the world, the West, I say. And we gave that up, and we were content being the designers of the world. That is not our trophy forever. That trophy can change hands very easily. If we lose that, then we are simply going to be at the mercy of every country that wants to influence us, and for good or not. I think now is the time to wrestle that trophy back. And we don't have to be the best and the biggest, but I think we need some form of independent capacity for strategic reasons, if not economic reasons, but for a host of reasons, beginning with strategic. And it's so expensive to claw that back. That $52 billion that the federal government's, think about it, that's enough for 2 foundries and a little bit of change. And so that is a small number, in a very, very impressive number, but it's relatively speaking a small number. We need so much more. And I think we need a mindset change first, because we have to really, 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 really want it and get a sense that we need to do this for so many different reasons. And then just start clawing it back. We built it once. We can build it again. It's more expensive to build it now than it was before, but we can do it. And the longer we wait, the more in the hole we'll be. And then there'll come a point where we won't be able to do it. And I don't think we're at that point yet, but I appreciate the work that IPC is doing in the advocacy side. They're certainly not getting any extra vacation time right now. And I appreciate the work you're doing with this article and those recommendations for North America to adopt. I think they're wise. I think they make a lot of sense. And I think it's still an uphill battle. So keep going after hearts and minds and funds. And hopefully we can turn this around and we can be a little bit more independent. Still working with partners globally. This is a global, we're all connected. This is a very small planet we're on, and we are all connected, and we all have a part to play. But we all need to be able to play multiple parts. We can't just be like an orchestra. We can't have one drummer, one strings, one brass. We need to, because that works when everyone is participating. But if all of a sudden the drummer wants to go off and only drum for his own group, that now the orchestra's in trouble. And I think that's kind of where we are now. So we really need to have a redundancy of talent, a redundancy of capabilities, so that no one country is relying on the rest of the world, on the rest of the orchestra to make music. We need to make music independently. And I appreciate the work that your team is doing and others. Again, for my audience, look at the show notes. If you're on YouTube, click show more. I'll give links to the information from IPC and how you can contact them and get involved, and I'll have links to the conference as well. So Matt, thank you so much for once again being my guest on the show. You're always a joy to talk to and a plethora of information. I really appreciate the work you do and the time that you've carved out to talk to me and my audience.
Thank you, Mike.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, or on our newest channel, Amazon Music, or virtually wherever you get your podcasts. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks for all of your questions and episode suggestions. Please keep them coming. You can send comments and episode suggestions to my email, mike@mikeconrad.com. Just remember that's Conrad with a K. And be sure and subscribe to the podcast on your favorite podcast app. Or if you're watching this podcast on YouTube, on the Reliability Matters YouTube channel, click on the subscribe button and the bell icon to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of each month. Once again, thanks for listening or watching. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in a couple of weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.